Hello guys, I'm Sandip, and if you do remember, we are on our chapter which is called as the laws of motion, right? So, so what we knew till now that different types of forces, then those normal friction and tension are the forces, and EMG is also there. Weight at all the forces we already know, right? Then today we are going to see that how that rocket launches, right? And you already know something. I told you in the previous lecture also that gases are getting ejected, right? They are applying some force on the ground. So, as the Newton's third law of motion says, that ground should also apply some force on that. But there is also one more important principle is there, which is called as law of conservation of momentum, and that is going to play a major part on that in that rocket launching, you can say. So we are going to say. Then now, let's see. So first of all, conservation of momentum that we are going to see. What is momentum? If you do remember, momentum is equal to, we have seen that formula, momentum is equal to mass into velocity, if you do remember, right? So I told you the example. Consider that suppose the bicycle is going and if you want to stop it, it's possible, right? You will fall down, but yes, it is possible to stop stop the bicycle which is running, right? But it is impossible to stop the car moving with some velocity, obviously. Why? Because the momentum of the car is more. Why? Because obviously you can say mass and velocity, both things are more. Let's consider bicycle only. Suppose bicycle is going very, very, very slow, then it is easier to stop. But even if the bicycle is moving very fast with the more speed, then it becomes difficult. Why? If the velocity is more, then our formula or momentum, what is the formula? Is equal to mass into velocity. If the velocity increases, momentum increases. It becomes very difficult to stop because it's effect of collision, we can say. It is related to something, effect of collision, we can say. That increases, right? Also, if the mass increases, we know. Consider, suppose if the cycle and car both are moving with the small velocity, very small velocity, you can stop the cycle anyway. But car, no, you cannot stop because mass is also moving. No? So mass and velocity both decides what is the momentum and how much impact it is going to impart, right? Even in case of collision also you can consider that example. Consider, suppose truck is here, right? So this is your truck. And one small, let's say, small bike is there. Small bike is coming. If both are running on the road in the opposite direction, what will happen if they collide? Right? Not much will happen to truck, but bike, I don't know. Bike will go fly away, right? Why it is happening? Because truck will have very big momentum, right? Why? Its mass is more, velocity will be also be there. But now consider if this truck is at rest. The velocity zero, truck is just there, and the bikes come with some slow speed, we can say, and then collide with the truck. What will happen? Maximum the bike will fall down, right? But not a much harm in that case. Why? Because if the velocity of truck is zero, momentum is also zero. So obviously, it will not cause a lot of harm to the bike, right? So who is causing the harm? Not the mass, because truck has the mass even if it is at rest. But mass and velocity, both the things, when they combine, they get together, then we can say yes, then it is dangerous for the Bike will not stay. Bike will fly somewhere, right? So like that. So this is the momentum which we have studied. If you also remember that we related that momentum thing with the force also, how to calculate the force if any object is changing the momentum. If you do remember, we took the example of the cricket, right? Dhoni is hitting the ball for the six. How it's happening? When the bowler throws the ball, he imparts some momentum, right? By momentum, because ball has the mass and the bowler imparts the velocity. And momentum obviously depends on how fast he is throwing. Obviously, faster bowler will throw it high. He will have the high momentum. Spinner will have the less momentum, like that. And Dhoni is also hitting that ball, right, with some force, right? And how much momentum he is applying. What is the velocity of the ball after hitting by the bat? It is going to go into like that, right? Toward the six, right? So that momentum, what Dhoni is doing, Dhoni is changing the momentum of your ball, right? Or you can say Chris Gill. Chris Gill is also he also have a lot of power, right? He just touch the ball and goes out of the boundary. So many batsmen are there. Okay, so they are actually changing the momentum, and force, how much force they are applying, it depends on how much momentum they are changing, obviously. So we have seen that part about the momentum, and we know that now. Okay? So if you know the momentum, now let's see what is this conservation of momentum, and what is happening in this launching of rocket, right? And so if you have seen in the previous session, I told you that that mass of the rocket plus gas system, that's not only rocket, right? Rocket, or we can say that gas chamber is also there in the rocket. That is also one of the part of the rocket also, right? So the problem here happens is that the mass of that rocket is not constant. As the gas is ejecting continuously, obviously that mass is variable, we can say. So we cannot directly apply the force is equal to mass into acceleration formula there, right? So we have to use this conservation. We have to take the help of this conservation. Okay. So this is about the momentum. What is the conservation? Conservation means it remains constant. You must have heard the energy conservation, right? Energy cannot be created, cannot be destroyed, but can be converted from one form to another, right? So that is the conservation of energy. Same thing happens with the momentum, but a little bit difference is there. What is that? We're going to see that anyway. Then second case is collision. Obviously, we have seen the example of this collision, truck and bike, right? So that is nothing but collision, and you already know now that it is something related to momentum also, right? Because truck has a lot of momentum, so it is going to impact. It's going to make a lot of impact on that bike. Then recoil. Now, what is a recoil? Is it something related to coil? Coil is what? Coil is, you can say, spring type something, right? Coil. But that's not recoil actually. So what is recoil? It is a recoil velocity. So you can consider the example of gun and the bullet. When you fire the bullet from the gun, right? What happens? There is a, you can see, bullet goes away obviously with a very high speed, but gun also have a little bit speed which with which it goes backward, right? Why it is going backward, that we are going to see. It is actually called as recoil velocity of the gun, right? Or you could have seen the examples of that. Yes, you can say the gun is a good example anyway, right? So yes, recoil velocity, we can consider the gun there. Then yes, general problems on conservation of linear momentum. Yes, we will solve some numericals also on this, so it will clear your knowledge about the linear momentum. Okay, sure. So let's start this session. So first one is a conservation of momentum, right? So same as like that of energy. Energy remains constant, right? We say similarly here, linear momentum remains constant, but there is one condition. What is the condition? If the net external force acting on a system is zero. If you remember the first law of Newton's first law of motion, he said that yes, that the body will be at rest or will be in motion. It will keep it in the motion, but he also attached one condition there: unless and until external unbalanced force act on that body. Same thing is here. Yes, momentum remains constant. It remains constant, but as long as external force acting on that system is zero. Now, two things we are supposed to concentrate on this. One is that external force, yes, that's easy to understand. And one more is the system. They haven't said the object. In all the motion laws of motion, they said that object at rest, object at in motion, or every object offers equal and opposite reaction, right? That thing. But here they have change that word to the system instead of object. What is system? That is the question. So normally what happens, this momentum, whenever this momentum is conserved, we are going to solve some questions on this momentum. Remember, there will be more than one object, right? There will not be only single object, but there will be more than one object, right? Why? You can see here in the first example, we have taken that bike and truck, two objects, not a single object, right? Bat and ball. Yes, there are two objects. Then also we talked about the bullet fired from the gun. Yes, two objects are there, right? So you can see system means there are more than one object. That is called a system. So instead of saying two objects, because yes, there could be a more than one two objects also. It's not necessary that it will be only one object or two objects. It could be more than two, 3, 4, 5, 50, doesn't matter, right? So whatever number, how many number of objects are there, doesn't matter. If the external force acting on the system is zero, linear momentum of the system, remember again, of the system means combination of the linear momentum of both of these is going to remain same, right? So again, one more word we can add here, linear, very important. We are not talking about the linear momentum of single objects. Linear momentum of the system remains conserved or constant. So what is the meaning here? You can see. Again, I am repeating that linear momentum of not the object but the system. So in our truck and bikes example, yes, both have some momentum, mass into velocity. Mass is constant. If the velocity is also constant, momentum is same before the collision. But what happens after the collision? Bike got a lot of velocity. Velocity increases. What will happen to momentum? Momentum also increases. So how we can say the momentum is constant? That's what I am saying. Not the momentum of not the object we are talking about. Momentum of the system remains constant. Okay. So remember this one. Then obviously momentum, when we are talking about the momentum, there must be some collision. So what is collision? Collision is the interaction between two masses, right, for very short interval, very short time you can say, wherein the momentum and the energy of the colliding masses changes. Again you can see momentum changes, right, but the mass of the colliding masses, objects you can say, but it is not necessary that or we can say the momentum, total momentum of the system should conserve, right? So here we can see very nice examples are there. First example, I think you may have played this carom, right? So what is happening? Yes, I think he's playing really nice there, right? So we got, I guess, 2 points there inside the pocket, and queen is also in the pocket. That's good, right? So what is happening? He's actually hitting the coins with the striker. You know the striker and coins, right? So there are white coins, one red coin is there, black coins are there, right? So the person is hitting the coins with the striker. What is happening? There is a collision. Collision means when he hit the striker, a coin with the striker, he actually imparted some momentum to the striker. That's correct, right? And that momentum is imparted to the other coins. And you can see now there are a lot of coins are there. So can we say system has a lot of particles there? Yes, obviously system has those many coins there. So many objects are there. Right? So as I said, it is not necessary that system will only have one or two objects. Okay? So yes, so is imparting the momentum there. Now the second case, what you can see here, and yeah. So in second case, what is happening? There is some game, you can say bubble. They have some bubble wrap around them, and the two persons are colliding each other. You can see the first person after collision it becomes wobbling, right? Something like that, right? So why it's happening like that? Because the other person is imparting a lot of momentum. What about the momentum before and after collision of the first person? Right? That person who is falling. Before we can say he has some velocity. So there is momentum. Right? After collision also that velocity becomes something like that and started wobbling like that. Right? So, but always also here also we can say when these two person collide, the momentum will conserve, but of the system. So combined momentum of the both the persons is going to remain same. It is not going to change. Okay, but for the separate momentum, yes, it is going to change. How that will happen, we are going to see through the equations also. Right. Now let's see at the third example. It's a lot of destructive example is there. So yeah, so very dangerous accident there. So what is happening? That small tempo got collided with the car, not once. It collided for two times there. Right? That tempo collided with the car and imparted the momentum. You can see the car came at the wrist. Right? So its momentum becomes zero. But initially it had momentum. After collision, car's momentum becomes zero. Right? But you can see that tempo's velocity increases. Its direction also changes, obviously. Yes, momentum can also change the direction, right? So, but overall momentum, you can say, is going to remain constant. So when that car comes to rest, can I say that whatever momentum that car had initially before the collision, it completely gave that total momentum to that tempo. So either tempo speed will increase or direction will change, something like that. You can see the initially when the exact at the time of the collision, you can see it properly that that tempo got a very high speed there initially, right? That's like it's like that you can say. Okay. Good. So these are some collisions. So now let's write some equations of the collisions. Consider there are two objects. Let's draw some spherical objects here. So consider this object has mass m1. This object has mass m2. Both are in, let's say, both are moving in the same direction. m1 is moving with velocity u1. m2 is moving with velocity u2. Now remember, when we said that momentum of system, what is the momentum of system? Both of those two objects are there. So obviously two calculations of the momentum, we can say two momentums will be there, let's say. So let's say this first ball will have the momentum, let's say m1 u1. Second ball will have the momentum, let's say m2 u2. Right? What will happen after some time? They will collide like this. Right? And again they will get separated. And velocity is going to change. Their velocity after collision, we have seen in the Many examples now that velocity is changing there. Right? So after collision, so let me write this as before collision. So this is called as before collision. And what is this? This is after collision. You can see what I have written. Initial velocities I have denoted by u1, u2, right? u1 and u2 are what? Initial velocities of masses, m1 and m2. Initial means, now in this case, before collision we are seeing, right? And v1, v2 I have represented. Mass is not going to change, right? That we know. Mass is not going to change here. So m1, m2 will remain as it is. And consider what will be the momentum for this. Can I say momentum will be m1 v1, and for this we can say momentum will be m2 v2. Now when we say combined momentum, combined initial momentum, what is the meaning of that? If I call this as p1 and p2, this is our initial condition. So let me represent pi. Pi is initial. It's m1 u1. Just add these two, right? This is p1 p2, right? So we can just add this p1 plus p2. So m1 u1 plus m2 u2 will be our pi. Pi means what? Initial momentum of whom? Of system. So that is why the system word is there, because we have to combine these two momentum. Right? Similarly, here what I can write, let's say this is p1 p2 again. Pf is equal to p1 plus p2, or let's say pf becomes m1 v1 plus m2 v2. This is initial momentum and final momentum we have. Okay. So what is our law? Law states very clearly that as long as external force acting on the system, not objects. I will repeat. I'm repeating that. It was very important concept. The external force acting on the system, right, is zero. Then we can say the linear momentum of the system will conserve. So system's linear momentum means this is the system's linear momentum. Also, this is the system's final linear momentum. Conserved means it will remain constant. So simply we can say Pi will be equal to Pf. So write the equations. Let's say m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Very simple to understand, right? Okay. So this is the very important, very good momentum equation which we are going to use, as I said, for 11, 12. So remember this part, right? Using this relation, we can solve a lot of numericals. Okay. Let's try one numerical. Okay, I will give you some values here. Okay, so first of all, consider m1 is 5 kg. Let's say m2 is 10 kg. This m1, let's say, is moving with, let's take 20 meter per second. And this is moving with, let's say, 15 meter per second. Okay. What they are going to ask? Find out the velocity of the first object after the collision. So these values they have given. And what they are asking? Find out the velocity of the first object means what? m1 you can say. Right? If they will also provide you the velocity, let's say, of the second object. If the velocity of the second object after the collision becomes, let's say, 10 meter per second. Okay. So what they have given, we already have m1, m2 before the collision. After the collision, are they m1 mass is going to change? No, they are not going to change. They are going to remain same, right? u1, u2 means initial velocities are given. That's good. Final velocity of the second object is given. That is 10 meter per second. Right? Okay. So let's try to substitute the values. So 5 into u1 is how much? 20 plus 10 into 15. is equal to again 5 into V1 we want to calculate plus 10 into what? Again 10. So this will become 100 plus 150 is equal to 5 into V1 plus 100. You can see 100 is getting cancelled. So V1, can I say V1 is equal to 150 divided by 5 is equal to 30 meter per second. We got the V1. So the meaning is that V1 is not going to change that. Right? Very simple to understand. Let's try to solve this question. This car and tempos, right? Right. What is happening before collision? Let's take some arbitrary values. Consider mass of the car. I'll use some values. Mass of the car, let's say 500 kg. So, and mass of that tempo, we can say, right? Small rickshaw type tempo. Let's say 300 kg. Right? Looking at the speed in the starting image, let's say initial velocity of the car. Initial velocity of the car means what? Before the collision. Okay, you can see the car was also very fast. So let's take it as 80 kilometer per hour. And let's say velocity of tempo. How much will be the velocity of that tempo, right? So, and we say that velocity, let's consider it as 60 kilometer per hour. It is also coming with very high speed, right? So we have all the things. Now, what is the velocity of the car after the collision? Yes, I have to think on that. What is the velocity of the car after the collision? Car comes to rest. So these are the initial velocities, right? Initial are represented by U. And we also know the velocity, final velocity, which is represented by what? V. V of car is equal to 0 because it is coming at rest. What will be the velocity of tempo? It is what we want to calculate now. So our formula is very simple. We have seen the formula. What is the formula? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Right? Okay. So what is happening in this case? Let's say mass of the car is 500. U1 is 80 plus mass of the tempo is 300 and U2 is, let's say, 60. Mass of the car is not going to change, 500, but the speed is 0. So this whole term is going to be 0. This is 300 into V2. Let's solve this one. This one becomes 8 5s are 40 and 3 zeros are there. Plus 6 3s are 18 plus 3 zeros are there. This becomes 0 plus 300 V2. So how much is that? Let's say it becomes 58,000, right? So 58,000, the 300 is going to go into the denominator, will be V2. So your 0 will get cancelled, right? And this will become almost 3 1s are 1. And this is 28. 28 means approximately we can take it as 3 9s are 27. 193.3. Right? So this is the speed that becomes of that tempo. Right? Initially, you can see, initially means after collision, you can see that the speed of the tempo is very high. This could be the speed, right? Obviously, the masses, we have to check the masses, whether those are correct or not. But initially, at the start, that will be the speed. Obviously, we haven't also considered the directions of the velocities here. Actually, you can also see that the car and tempo, when they collided, they were exactly at the 90 degree. You can see that, right? So that 90 degrees is also going to change a lot of values. We are not going to go into the detail of that 90 degrees right now, but we can just try to do the small calculations here, right? Okay. So these are the calculations for our collision. Okay. So using this, you can actually calculate anything. Now, also, let's try to solve one more question on this. Consider this is the mass M1. Let's say 2 kg ball moving with 10 meter per second. And this is the second ball moving with, let's say, 3 kg ball moving with 20 meter per second. Right? Consider after collision, the velocity of the first ball becomes, let's say, 2 meter per second. What will be the velocity of the second ball after collision? Let's use the same formula. But I have taken this formula particularly, so this second question actually, because I want you to get one concept very clear, that in the previous collision of that tempo and car also, I said that you can see that initially the velocity that both car and tempo are colliding with each other in 90 degree. So obviously values will change. Here also, in first problem also, in this first case also, they are in straight line. Here also they are in straight line. But what we have to consider here is very important concept, that they are coming like this, opposite sides, like this. Or we can consider this second example, when two persons collided with each other, they were coming in the opposite sides. In the first question, what I said, that two balls are running both in the right hand side or opposite x direction, you can say. But this is the different scenario. What we have to do in this case. So in the first case, what you could have is 20. This is u is 20, u2 is 15. I took that values like that because 20 is greater than 15. If consider if the first object has a small velocity than the second, will collision happen? Never. It will never happen, right? Obviously, consider if the one car is going ahead and the other car with the slower speed is going behind it, it will never catch it, right? So therefore, I have taken that u1 as 20. But in the second case, the u1 is 10 meter per second, but u2 is greater. But still, they are going to collide because now they are in opposite direction. So what is the change we have to make? Consider. So this is 2. u1 is 10. m2 is how much? 3. And what about the u2? u2 is 20. But remember, as it is in the opposite direction, we should consider it as negative. So those sign conventions, right? Those are important here again. So what we can say, right, we can take it as positive. Left, we can take it as negative. So m1 is 2. V1, how much is the V1? V1 is 2 plus 3 into what is V2? Right? V1 is how much? 2. It is, they haven't given the negative sign. So V1 we can obviously take the positive. So this becomes 20 minus this is 60 will be 4 plus 3V2. Right? So how much will be the answer? Let's try to solve this. 20 minus 60 will give you minus 40. This 4 is here, it will go on the side, is equal to 3V2. And V2 will be where? V2 will be minus 44 divided by 3. Let's consider this as almost, we can say almost 15, 14.9 something. Minus 15 meter per second. So this is the final velocity of the second object. Means that ball is going into the left side, right? So that is how, what is the difference you can say. Okay. Now let's see some real life examples on that. And so I told you about a gun and bullet. When you actually fire the gun, fire the bullet, gun also comes backward. Right? Gun also gets some velocity backward in the opposite direction. And why is that happening? It is called as recoil velocity. Very simple. So we can also use this, our original relation here. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Right? Or we can use this. So two objects are there, gun and the bullet. So initially, what we can say, so this is the gun, right? So bullet will be somewhere in here inside, right? So initially, we can say, let's say gun has mass m2, bullet has mass m1. Initial velocity of both, let's denote it by u1, u2, we already know. Initially, can I say both are at rest? So u1, u2, both will be at rest. But in second case, when you fire this bullet, right, what is going to happen? The bullet is going to go very fast here, right, with some velocity v. Okay, so can we say v1? v1 is equal to v in this case, and v2 is the velocity of gun, right? So see this gun, right? Okay, so what we can do, final v2 we don't know, and this is the v1 of the bullet. So let's use our formula. What is the formula? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1 is as it is, but you know u1 and u2 both are 0. I think this will also become 0, this will also become 0. So m1 into v1 is equal to m2 v2. So what we want to calculate v2, right? So what I can say, m2 v2 will get minus m1 v1, or simply you can write it as v2 is equal to minus m1 upon m2 into v1. So you can also see that minus sign did appear there. What is this minus sign represents? If the v1 is positive, this is v2. Yeah, v1 is positive, v2 will be negative. Means they will be in the opposite direction. Bullet is going forward. You can see in the example that gun is going backward. So it's not like that you found a gun and you started shooting. It's not that easy, right? Obviously, they have some training in the armies also. This is a very small gun, but in armies they have a very bigger gun. You must have seen the in movies, or maybe you must have played some PUBG or other games, right? In that games, those guns are very bigger. Play PUBG is very easy, but in real, to fire bullet with that bigger guns, it's not that easy. Actually, you must have observed that those sniper guys or the our army peoples are actually sleeping on the ground and then aiming the gun. Why? Because that recoil velocity could hurt the shoulder. If you put that bigger gun on the shoulder, that recoil velocity, yes, it is that much that it could hurt the shoulder. So they are keeping the very perfect position for that, and then they will actually fire the gun. Okay, so this is the case. And in second case, also rocket propulsion is there. So in again rocket propulsion, what we can say, there are two things are there. Let's say rocket, and second one is a gas. That gas which is ejecting, we can say, right? So let's say rocket has mass m1 or gas has mass m2, right? So initially, when the rocket is just before initially the launching, we can say initially both u1 and u2 is equal to 0 again. So if you use the formula, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So this will become 0. We can say m1 v1 plus m2 v2. But as I said, if you do remember that rocket is not that easy, right? That mass is actually decreasing, right? So obviously we have to use some variable concept there. So we're not going to go in that much of detail, but remember, mass of the rocket is decreasing. Decreasing mass is represented by dm. It is variable mass, right? And this is your m2. So that's we have to do a lot of calculations there to get the rocket propulsion, how it works. But this is the basic principle that conservation of momentum is concerned. And obviously you can also see that v2, let's forget about this m1 minus dm. Let's keep it as m1 v1 here. Okay. So again, if you calculate the V2, V2 will become M1 minus M2 into V1. So V2 will be opposite to the V1. So the gas is going downward with some velocity. V2 means the rocket will go upward. That is the basic principle of the conservation of momentum. As I said, it is a variable mass system. So again, it will it's not this simple equation they use. No, that's a very complex equation. Okay. So good. Now let's move to the next one. So we have seen the formula. Formula is very important. Now here the canon is there. Canon is also, it is also the similar concept, right? You must have seen in the movies also when the this is not a bullet. What we can say to this, that bigger spear, when it is fired from the cannon, right, that cannon goes backward. Nowadays, so we do use the guns. We means people which who needed it, right? We do not use the guns. But yes, guns are in the practice, but cannon is not nowadays, right? But in the movies, you must have seen that when the that spear is thrown or fired, that cannon goes backward. This is the same thing, same formula you will get as that your gun's velocity, right? That's not going to change. And normally, basic principle we are going to use here is our conservation of linear momentum, and that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Here, what you can see that the mass, let's say this is at m2, this is mass m1, small m, right? Initially, when that spear, not a bullet, spear is in the cannon, both are at rest. So again, what we can say, u1 is equal to u2 is equal to 0. Let's substitute it in our equation. M1 U1, M2 U2, M1 V1 plus M2 V2. What they are saying, this is your V, V1 small v, V2 is what? Capital V. U1, U2 both are 0. So 0 plus 0 is equal to M1 is what? Small m, V1 is small v, plus M2 is capital M, V2 is V2. So V2, you can write this as minus M upon capital M into V. Right? So you can see this is the same formula as we already got in case of gun, right? There is no difference in that, right? So we can use this formula to solve the questions, but better instead remember our basic formula: m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. You can solve all the questions using that basic formula. Okay. So this is the conservation of linear momentum. We talked a lot about the linear momentum also. So let's try to solve some questions on that. So we'll understood what is that. So first question says 1.2 kilogram basketball traveling 7.5 meters per second. It's a back of 12 kilogram wagon, right? Wagon means just like a cart, you can say, right? Consider this the cart. And basketball is there. So basketball is moving with what? 7.5 meter per second. Mass is also given. Mass is 1.2 kg. And cart's mass is how much? 12 kg. Right? Initially, car is at rest. Right? So let's write the given. So I told you that in physics, try to draw as many diagrams as you can. So it will easily clear your, now this is, you can see, this is very easy now to understand, right? Okay. So let's see 1.2 kg. So M1, let's say M1 is 1.2 kg. U1 is how much? 7.5 meter per second. It's the back of 12 kg wagon. So second mass is how much? 12 kg. Initially, the cart or wagon, we can say, was at rest. They haven't mentioned that cart was moving, wagon was moving, right? Okay. And bounces back. Who bounces back? Basketball. After collision. After collision means we say V1. And remember, this bounces off means when it strikes it here, right? It is going to come back like this ball. right? So V1, now you can see the V1 is in opposite direction in the left side. I told you when it is in left side, you have to take it as minus 3.8 meter per second. And sending wagon off in the original direction of travel of the ball. Right? So original direction, ball's direction was positive, wagon will go into this side. We know that. So calculate the V2. Now it's very easy. We already know the formula. We draw on the diagram. Once you done this negative sign is important here. Once you do all these things, then it becomes very easy. M1 V1 plus what you can say M1 U1, not M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. M1 is how much? 1.2. U1 is given as 7.5 plus M2 is 12 into U2 is 0. 0 is very good for us, right? That reduces our calculation a lot. M1 is how much? 1.2 again. Velocity is negative, right? Minus 3.8 plus M2 is again 12 and V2 is what we wanted to calculate. That's it. So let's try to solve this one. So I can see 1.2, 1.2, 112. Right. So actually, we can do this calculation a little bit easier now. How to do that? So let's see. Consider I can write this as 12 and this as 0.75. What I have done for the 12, I have taken the one decimal. I have shifted it to the right side, but I have to balance that too, right? So from the 7.5, I have shifted the decimal to the left side. Okay, this is 0. Then again, this is 1.2. Let's do the same thing. So this is a minus, and I can write this as 12 into 0.38 plus 12 into V2. Then why I have done that? Now you can see that will make my calculations very easy. What I'm going to do, I'm going to divide every term by 12. You can see 12 is everywhere. And as there is equal to sign, I can divide it, to both the sides, right? So what will happen? 0.75 is equal to minus 0.38 is equal to 12 V2. Right? So now it is easy. 12 V2. So it was easier because I don't have to calculate that 12 and all those multiplication. That could have been dangerous, right? 0.75 plus 0.38, it will give me, now these are our easy calculations, 1.30. Or V2, I can say 1.13 divided by 12, or we can say 0.0. We know that 12 sevens are 84, 12 zets are 84, 96, then we have 108, right? So 12 nines are 108, carry remainder will be 4, it's a 3 something. So 0.093 meter per second will be the velocity of that wagon. You can see it is very, very slow. Why? Because the mass is very less, right? So basketball, how much impart it can, how much velocity it can impart there. Therefore, we got this much of velocity. Okay. So, one question is there, but the sign, whether it is positive, negative, we have to consider those signs. Those signs are going to decide a lot of things. If you change the sign negative to positive, then everything will be wrong. Okay, good. Now let's try this one. The bullet of mass 100 gram is fired from a gun of mass 20 kg. So either you can memorize that formula. What is the formula? V2 is equal to M1 upon M2 into V1. That is your formula, right? Or what you can do, you can directly substitute. Remember basic formula M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Anyway, this is the recoil of the gun, So this is the formula you can use. Actually, what is V2 now? Yeah. So we can say M1 V1, or let's say minus sign is there. M1 upon M2 into V1, where M1 is what? Mass of the bullet, M2 is the mass of the gun, right? So let's write M1 is equal to what? 100 gram. 100 gram, obviously we have to convert this into our normal SI unit. So that will become 0.1 kg. Right? How you do that? 100 divided by 1000. So this will become 0.1 kg. What is M2? Now gun's mass is very big. Heavy, we can say heavy gun is there 20 kg. So bullet is fired from the gun of mass with velocity 100 meter per second. So U1 they have given. Sorry, V1 they have given, right? 100 meter per second. Calculate the V2. So we know the formula. Let's try to substitute it here. So M1 is how much? 0.1. This is 20 kg into V1 is 100. Right? So obviously what will be our answer? Minus 0.5 meter per second. Minus sign represents that recoil velocity is in the opposite direction. If you fire the gun, bullet in front, gun will go back, right? And you can see, compare the velocities. Velocity of the bullet is very high, 100 meter per second. What about gun? It is just 0.5 second, very less, right? It's not like gun is going to go back with the speed of bullet. This is obviously recoil velocity of the gun will be less in that case. So either you can remember this formula or our normal formula. In that case, U1, U2 will be 0. And these are the velocity. Right? So this is your whole chapter. So we have studied the conservation today. And if you do remember, we had the 5 sessions of the chapter laws of motion. Remember, very important chapter, as I repeatedly saying, that it is important for your not only 9th, 10th, but also 11th, 12th entrance exams and free-body diagrams in the previous session we have studied. Those are even important for your engineering purposes. Remember, all those parts are important. Do try to solve as many questions as you can. You have seen the forces, normal force, then a friction force, tension. In friction, we have seen the static, kinetic friction. Study those very carefully. Remember, those are going to help you a lot in your entrance exams in the futures. Right? Okay. So hopefully, I think you understood the whole concept and you enjoyed the lecture. So these are very nice concepts of the laws of motion. So study on that. Try to solve as many numericals as you can. If you do have any queries, please post them in forum so I can solve them as soon as possible. So we'll stop here anyway. Thank you very much. Have a nice day.